Welcome to a session on triangles. In previous session, one of the sessions, I think we had completed understanding the similarity of triangles and had discussed all the theorems under it. And herein we take up questions on similarity of the triangles. We haven't discussed the area of the angles yet, so that's where we'll be taking up some of the in few of the next sessions. First, let me give me a figure, and on that basis I will write the question. This is given to be 90. Let's write A, that's B, this triangle, that is C, there is this line which is intersecting at the point F, because this has been named E and the one is D. Now the question writes as AD and CE are the two altitudes, so it's better we mark this as well here. They are the two altitudes of triangle ABC. Prove that. What are we going to prove? We're going to prove first is AEF similar to CDF. Then we have ABD similar to CBE. The third part we have is AEF similar to ADB. The fourth becomes triangle. They all have triangle symbols which I didn't write. Triangle BEC. You can add these symbols here. Let's take up the first one. What is there in triangle AEF? In triangle AEF and triangle CDF, do you let me just highlight that so as to you can observe it better. This is CDF and this is AEF. It's quite visibly there are two angles. This one angle is 90 degree, so we can write angle AEF is equal to angle CDF, they both being 90 degree, as it is given that CE and AAD are perpendicular. What else? AFE and CFD, they will also be equal. We call vertically opposite angle, so we write angle AFE is equal to angle CFD, they both being vertically, there should not be a space, vertically opposite angles. So this is this helps us to prove triangle AEF similar to CDF by AA criteria. So one is proved by AA criteria. Now move on to the second proof. It says ABD. Okay, let me again kind of use another color to show you. This is the pink one I'm drawing. This is ABD with CBE. CBE. These are the two triangles, and in the second part what we can see is, so the common angle, this is a common angle, so C, in second one I can write CBE is common to both the triangles. What else? You also have this ADB, angle ADB is equal to angle CEB. Just be careful, you write these sides of the angles which are part of the triangles given. They both are 90 degree, it is already given. So again, by AA criteria we can prove ABD similar to CBE. Move on to the third part. It is AEF, the small AEF with ADB. So you want me to highlight it for your observation, or I want you to observe it better? This one and this big pink one here. AEF and ADB. In that case, number 3, angle A is common. If you observe it, angle A is common. And again you can write angle A is common, and angle AEF is this side is equal to angle ADB, there again 90. So again by AA criterion, third part is proved, that is AEF is similar to ADB. Now move on to number 4. It is FDC, the small one with BEC. They're the big one, this one and the big one there. In that case also C is similar to the previous one, C is common, and angle AEF is equal to angle BEC. They both 90 degrees. So again by AA criterion, this fourth part is proved. Yeah, I hope you are getting things right now. I move on to another question. The question writes, there is no figure, we need to make figure for ourselves. P and Q are points on sides AB and AC respectively of triangle ABC. If AP is given to be 3 centimeter, PB is given to be 6 centimeter, AQ is 5 centimeter, and QC is 10 centimeter, we have to show that BC is equal to 3PQ. So let us draw a triangle which is ABC. I draw ABC. B and C. A, this is B and this is C. It says P and Q are points on side A, B and CD. So let us draw PQ here. It's given AP to be 3 centimeter, PB to be 6 centimeter, and AQ is 5, QC is 10. We have to find BC and PQ. Let us first prove why I'm doing so will be if I can prove the congruency of APQ and ABC, we can apply the proportionality and thereby finding the values. Okay. Now in APQ and ABC, so we write in triangle ABC and triangle APQ, angle A is common. Also, if you observe separately here, you see AP by PB is equal to AQ by QC. It's 3 by 6 is 1 by 2 and 5 by 10 is also 1 by 2. Now A, that means if AP by PB, that is quite okay. That means if this is proportional, that means what? This angle is equal to this angle, this angle is equal to this angle. Okay, if the proportionality of the sides been proved, that means by the converse the proportionality theorem, we say PQ is parallel to BC. In that case, the angles which I have marked will be equal due to being corresponding angles. Angle A is also common. So thereby AAA criteria is simply I'm writing PB is equal to B. You can write APB, APQ and ABC as names, complete names. And then you write Q is as well equal to C. Similarly, you write AQP and ACB. So by AAA criterion, we can prove this. Now, once this is proved, the similarity, we know that means what? AP by, now if APQ is equal to ABC, then AP by AB should be equal to PQ by BC, and that should be equal to AQ by AC. Now AP is 3, AB will then be 9 because it's 3 plus 6. We have to take it, we have to find actually PQ and BC to prove that BC is equal to 3PQ. AQ will similarly be 5 and AC is 15. Let's take up, this is 1 by 3 and that's also 1 by 3. So PQ by BC is 1 by 3. If I cross multiply, I am getting 3PQ is equal to BC, or if I write it the other way around, it becomes BC is equal to 3PQ. That proves our question here. BC is equal to 3PQ. Thank you. We take a few more questions in the next coming sessions. Bye bye.